or you can print it from the Google Drive. We are starting with chapter 2 on fractions. We continue. We already solved problems 1 and 3, and now we're going to solve 5 and 7. Problem number 5 is even more challenging. Remember, the 3 first steps to problem solving is the 3 W's. Whenever it's applicable, you can ask yourself, who is the problem talking about? What is the problem talking about? And why am I solving it? Which is basically, what's the question they're asking us to answer? So let's go. 1/3 of the students go to school by bus. 1/4 of the remaining students go to school by car. The rest of them either ride a bicycle or walk to school. If 90 students go to school by car, how many students are in the school? So I would like to always, highlight the question as I'm solving my problems. How many students are in the school? My goodness, they give you so much information. How are we going to start? Well, we're going to start with who, what, and why. Who is the problem talking about? It's talking about students. What is the problem talking about? It's talking about how they get to school. What does the problem tell you about students getting to school? Well, we know. Let's start making a simple bar model. If these are all of our students, we know, let's highlight this, that 1/3 of the students go to school by bus. 1/3. So we're going to split as fast as I can this entire class or entire student population at the school, and I'm going to label 1/3, and I'm going to mark it, they go to school by bus. Maybe I can even shade it. Sometimes I do this on a whiteboard. Very good. What are they asking us to find next? 1/4 of the remaining students go to school by car. My friends, not 1/4 of the class. They're telling us 1/4 of the remaining students. So who are the remaining students? This is the portion that is not getting to school by bus. So we know that this remainder, obviously 1/3 is by bus, therefore 2/3 gets to school using other means. What do we know about the remaining 2/3 of students? That 1/4 of them go to school by car. Watch this. We're going to split this blue section, this 2/3, in 2 quarters. Well, it's already split into halves. We're going to split it into quarters. Okay? We can also do the following. Sometimes I do this for my students. I just copy the remainder down. Just copy it like that. Now I know this is my remainder. These are my 2/3. And then I split them into quarters. Okay? It kind of makes it for slightly cleaner drawing. So we know that 1/4 of them go to school by car. Let's label the car rides. Which color should I use? Red. Purple. I like purple. No, not this purple, this purple. So these students go to school by car. Right? These are car drivers or riders. The rest of them either ride a bicycle or walk to school. If 90 students go to school by car, let's quickly add this information. This piece is 90. How many students are there at the school? My friends, logical thinking. We can just solve this problem by looking at the drawing. If 90 students go to school by car, and that's 1/4, that means each quarter has 90 students as well. So I can just simply say 90 times 4 quarters gives you 360 students. That is the 2/3, 360 students. This is that portion. Remember? That's that portion, 360 students. Now, if 2/3 are 360, let's write it down. So we can say 2/3 of the student is 360 kids. Therefore, 1/3 of the students is 180 kids. That means this section, the bus riders, is 180. How many students are at the school? Step 3, 180 plus 360, and altogether we have 540 students at the school. Let's make sure we put the answer into a box or into a circle. My friends, this is a perfect method of using Singapore Math bar modeling to solve problems about fractions. These are not very challenging, but these are pretty challenging problems for 6th grade. My friends, problem number 7, which I love. It is even more challenging and I'm super excited. So, I'm on problem number 7 about Esther. Let's read the problem first, as we always do. Esther had 5 times as many cards as Richard. Esther gave 1/4 of her cards to Richard. Then Richard gave 1/6 of his cards to Esther in return. In the end, Esther had 90 cards more than Richard. How many cards did Esther have at first? My friends, who, what, and why, the 3 W's of problem solving. Who is the problem talking about? It's talking about Esther, and R for Richard. What is the problem talking about? It's talking about some cards, their cards. What is the first thing that problem tells us about Esther's cards? Look at the first sentence. Esther had 5 times as many cards as Richard. Well, remember, bar modeling is super easy if you know how to use it. It's very visual. Esther and Richard right now have exactly the same number of cards. But they don't according to this problem, right? So what we need to do, Esther has 1 time, Richard has 1 time, but Esther has 2 times, 3 times, 4 times, 5 times as many cards. So Esther has 5 units, Richard has 1. Very good. What happened next? Esther gave 1/4 of her cards to Richard. Let's go. She gave 1/4. This is second sentence. She gave step 2, right? She gave 1/4 of her cards. Well, she had 5 units, right? She gave 1/4 of 5 units to Richard. Okay? So 1/4 of 5, 1/4 of 5 is the same as 1/4 times 5, and it's 5 quarters. 5 quarters. We can keep it as 5 quarters. We can also make it into 1 1/4. So now we know that Esther gave 5 quarters to Richard. So let's write it down. How many cards does Esther have now? We can say, step 3. Esther had 5 minus 5 quarters. 5 is the same as 20 quarters, right? Converting it to equivalent fraction, minus 5 quarters. Therefore, Esther now has 15 quarters. That's Esther. But what happened to Richard? Richard, my friends, step 4. Richard had 1 unit, and now he has plus 5 quarters. Okay, he has plus 5 quarters. Let's label this Esther and Richard. Therefore, 1 plus 5 quarters, well, 1 is 4 quarters plus 5 quarters. Richard now has 9 quarters. Okay? But that's not all. What happened? What happened afterwards? Then Richard gave 1/6 of his cards to Esther. Okay? That's sentence number 3. I'm picking up a different color. Notice there is more exchanges happening. What did Richard do? 1/6 of his cards. Okay? So let's make this. Now, Richard gave away 1/6 of his 9 quarters, right? So it's 1/6 of, Richard now has 9 quarters. 9 quarters. Therefore, Richard gave away, let's do, look at this. Sorry, apologies. Therefore, This is divided by 3 is 3, divided by 3 is 2. Therefore, Richard now he gave away 3/8. Okay? So let's compute the next thing. After the second exchange, Richard, right? That's step 5. Let's pick up this color. Step 5. What happened? Richard's 9/4 minus 3/8, which is the same as 18/8 minus 3/8. Richard now has 15/8. Okay? Now Richard has 15/8. And what about Esther? Well, she got a gift, right? So she now has a little bit more. Esther, step 6. Oh, let's do this one. Step 6. Esther, remember, she had 15/4 right here, right? Esther had 15/4. And what did she gain? She gained 3/8. Therefore, 38 plus 3/8. Esther now has 33/8. My friends, let me label it with a highlighter. At the end, Richard has 15/8 and Esther has 33/8. Next piece of the problem. In the end, Esther has 90 cards more than Richard's. Well, we do see that Esther has more than Richard. Let's find the difference. Let's find the difference between their cards. Very tricky problem, my friends, very tricky. So, 4, 5, 6, step 7. We can say Esther has more, 33/8 minus 15/8. And that is, my friends, 33 minus 15 is how many units apart? That's 18 units, right? 18/8. That's the difference. And 18 of these units is the same as 90 cards, which means 1 unit, or 1/8, is 5 cards. 5 cards, okay? 5 cards. My friends, the final thing. How many cards did Esther have at first? Remember, she had 5 units or 20/4. So this is an important piece of information. Okay? Esther used to have 5 units, right? Which is 20/4. We learned that about her. Now, each of those units is 5 cards. Each of those 20 units is 5 cards. Therefore, no, not 20/4, but 1/8 is 5 cards. 1/8, so therefore 48. That were Esther's cards. 48, step 8. Step 8 is the final step. 48. 1/8 is 5 cards, right? Let's put a star. This is important. Therefore, 48 times is going to be 200 cards. Or 5 times 40. My friends, Esther had 200 cards. Esther had 200 cards. Very difficult problem. Very, very interesting and challenging problem. I hope you enjoyed it.